You're standing beside an old farmhouse tucked away in the rolling hills of Kentucky. It's the middle of August. The afternoon sun has been beating down for hours. The porch railing is almost too hot to touch, and the air shimmers above the fields like waves rising from the earth. Most folks would expect to hear the steady hum of an AIR conditioner working overtime. But there's nothing. No compressor, no refrigerant lines, no thermostat clicking on and off. And yet, the moment you step inside the house, the temperature changes. Cool air drifts through the rooms as if someone quietly turned on an invisible air conditioner. Only they didn't. What keeps this old farmhouse comfortable isn't hidden in a utility closet or bolted to the side of the house. It's hidden beneath your feet. About 6 feet below the surface, the ground barely notices the changing seasons. While the summer sun can push the air close to 100 degrees, the soil below remains remarkably stable, often staying in the mid-50s to low 60s depending on where you live. That simple fact has been measured by researchers, including studies from Oak Ridge National Laboratory, and it has inspired practical cooling methods for generations. Now imagine using that natural underground temperature to cool the air entering your home. No expensive compressor, no chemical refrigerants, just a buried pipe, a small inline fan that uses very little electricity, and the steady temperature of the earth itself. For a few $100s in materials, many homesteaders have experimented with earth tube systems that can pre-cool incoming air before it enters the house. The exact performance depends on soil conditions, climate, installation quality, and local building requirements, but the basic idea has fascinated builders for centuries. Welcome to Old Ben's Secrets, the channel dedicated to preserving forgotten knowledge, practical wisdom, and time-tested self-reliance skills that helped families thrive long before modern systems took over. Every week I share simple, affordable, and proven methods for homesteading, food preservation, gardening, off-grid living, emergency preparedness, natural solutions, and true independence at home. From forgotten techniques and old-world craftsmanship to practical survival skills and self-sufficient living, you'll discover real solutions that still work today. Forgotten knowledge, real solutions, self-reliance. Now, my name's Old Ben. I was born and raised right here in Kentucky, where the old-timers believed the land was the best teacher a person could ever have. Growing up, I heard stories about spring houses that kept milk cold without electricity, root cellars that preserved vegetables through the hottest summers, and homes that stayed surprisingly comfortable simply because their builders understood how nature worked. Back then, I thought those stories belonged to another time. But the older I've gotten, the more I've realized those folks weren't just telling stories. They were passing down knowledge that solved real problems using simple ideas instead of expensive machines. Today's story begins with one of those forgotten ideas. An idea so simple that many people dismiss it before they ever understand it. Yet versions of this same principle have appeared throughout history. Ancient Persian engineers used underground structures to help preserve ice during brutal desert summers. European farmers relied on cool earth and underground storage to protect food long before refrigeration. Early homesteaders across America used root cellars, spring houses, and earth-sheltered spaces because they understood something we often overlook today. The earth changes temperature far more slowly than the air above it. And once you understand that, you start seeing opportunities almost everywhere. So here is the question: if people have understood this principle for centuries, why don't more homes use it today? Was it simply replaced by modern technology? Did convenience make us forget? Or did we slowly stop teaching these old methods because newer systems became the standard? That is the mystery we're going to explore together. So pour yourself a fresh cup of coffee, pull up a chair, and let's uncover another forgotten secret. Now, let's take a walk outside. Stand with me in the middle of this old Kentucky field. The summer sun has been beating down for weeks. The top layer of soil is dry, the grass is struggling. Everything around you feels hot enough to fry an egg. But grab a shovel, dig down a few feet, then keep going. Around 6 feet below the surface, something remarkable happens. The heat almost disappears. It doesn't matter if it's July, it doesn't matter if it's January. The deeper soil changes temperature so slowly that it stays surprisingly stable throughout the year. That's not folklore, that's physics. Modern researchers have measured underground temperatures across the United States for decades. While the exact temperature depends on where you live, many areas maintain ground temperatures somewhere between the mid-50s and low 60s year-round. That steady underground temperature is one of nature's greatest hidden resources. Most people never think about it, because we spend our lives living on the surface. The old-timers didn't. They paid attention. Long before thermometers and weather stations, farmers already knew something was different beneath their feet. They noticed root vegetables stored underground lasted longer. Milk stayed fresh inside spring houses. Root cellars remained cool even during the hottest summers. Nobody needed to explain thermal mass. They simply knew it worked. Today we understand why. The earth is incredibly dense. Unlike the air above us, it doesn't heat up or cool down overnight. Summer heat moves downward very slowly. By the time that warmth finally reaches several feet below the surface, autumn is already arriving. Winter works exactly the same way. Cold temperatures take weeks to travel downward. The deeper ground barely notices what the weather is doing above. Think of it like a giant rechargeable battery. Only instead of storing electricity, it stores temperature. Every single day, every single year, without making a sound, without burning fuel, without needing maintenance. That's the simple idea behind what's known today as an earth tube system. Instead of pulling hot summer air directly into your home, the air first travels through a smooth pipe buried underground. As it moves through that pipe, the surrounding soil slowly absorbs some of the heat. By the time the air reaches the house, it can be noticeably cooler than when it entered, not freezing, not air conditioner cold, but cool enough to reduce indoor temperatures and lessen the load on mechanical cooling systems in the right conditions. And that's what surprised me the most. The idea sounds almost too simple. No complicated electronics, no expensive computer controls, just a pipe, the earth, and time. Sometimes the simplest ideas survive the longest because they don't depend on complicated technology. They depend on understanding how nature already works. But here's something even more fascinating. Kentucky wasn't the only place where people discovered this. Thousands of years before American homesteads appeared, ancient builders living in some of the hottest regions on Earth were already experimenting with similar principles. In parts of ancient Persia, engineers designed underground passages and cooling structures that worked with the natural temperature of the ground. Their goal wasn't comfort, it was survival, keeping food fresh, protecting water, preserving ice through brutal summer heat. Different civilization, different language, the very same lesson: work with nature instead of fighting it. The farther I looked into history, the more often this same pattern appeared. Roman builders, European farmers, mountain homesteaders, even communities living in deserts and high mountains, none of them had modern air conditioning. Yet many discovered ways to use the earth itself as part of their homes. That made me wonder, if so many civilizations independently reached the same conclusion, why did modern construction move so far away from these ideas? Was it because newer technologies simply proved more practical? Or did we become so focused on mechanical solutions that we stopped teaching the old ones altogether? That's where this story takes an unexpected turn. Because once mechanical air conditioning became part of everyday life, Forgotten knowledge didn't disappear overnight. It slowly faded into the background. And in the next chapter, we'll explore how that happened. Now, here's the question that kept bothering me. If this idea is so simple, if it has been used in one form or another for centuries, why don't we see it in every neighborhood across America? The answer isn't as simple as most people think. The early 20th century changed everything. In 1902, an engineer named Willis Carrier developed one of the first successful mechanical air conditioning systems. Ironically, it wasn't invented to keep people comfortable. It was built to solve a problem inside a printing plant. Humidity was causing paper to expand and contract, ruining print quality. The machine solved that problem beautifully. Before long, engineers realized the same technology could cool buildings as well. By the 1920s and the 1930s, mechanical air conditioning was no longer just an industrial invention. It had become a symbol of modern progress. Advertisements promised cleaner air, greater comfort, a better quality of life. And for millions of families, those promises became reality. There's no denying that modern air conditioning transformed the way people live. Hospitals became safer, factories became more productive, homes became far more comfortable during extreme heat. That's an incredible achievement. But as new technology spread, older knowledge slowly began to disappear. Builders stopped designing homes to work with the land. Deep porches became smaller. Shade trees were removed for larger driveways. Thick stone walls gave way to lighter construction. Cross-ventilation became less important. And many passive cooling techniques simply weren't passed on to the next generation, not because they stopped working, but because fewer people needed them. When a machine could solve the problem with the flip of a switch, most people stopped asking whether there was another way. That's something I've noticed over and over again while traveling through rural Kentucky. Ask an old farmer how to cool a smokehouse. He'll probably tell you. Ask him how to build a root cellar. He'll show you where his grandfather dug one. Ask him why the spring house always stayed cool. He'll smile and tell you to stick your hand in the water. That kind of knowledge wasn't written in textbooks. It was passed from one generation to the next. Sometimes around the dinner table, sometimes while repairing a fence, sometimes while digging a foundation. And when those conversations stopped, so did much of the knowledge. Today, interest in passive cooling is beginning to grow again. As energy costs continue to rise, architects, engineers, and homeowners are taking another look at ideas that earlier generations understood remarkably well. Earth tubes, earth-sheltered homes, natural ventilation, solar design. None of these ideas are magic. None of them replace good engineering. But together, they remind us of something the old folks in Kentucky never forgot. Nature has been solving problems for a very long time. Sometimes the smartest thing we can do is pay attention. Now, let's say you're sitting there thinking, Ben, this all sounds interesting, but could somebody actually build one today? The short answer is yes. But like most old homestead knowledge, the details matter. A traditional earth tube isn't complicated. That's probably the most surprising part. You don't need a machine the size of a pickup truck. You don't need thousands of dollars in specialized equipment. You don't even need to tear your entire house apart. The basic idea begins with a trench, usually around 6 feet deep enough to reach the soil where temperatures remain relatively stable throughout the year. Inside that trench, builders install a length of smooth-walled pipe, not corrugated drain pipe, smooth pipe. There's an important reason for that. Any system moving air underground has to deal with moisture. Warm air naturally creates condensation when it meets cooler surfaces. If that water becomes trapped inside ridges or grooves, it can create problems over time. That's why experienced builders recommend smooth pipe that allows moisture to drain freely. The pipe is usually installed with a gentle slope, not because it helps cool the air, but because gravity quietly carries any condensation toward a drainage point. simple, practical. Exactly the kind of solution old craftsmen appreciated. One end of the pipe stays outside, protected with a screened intake to keep out leaves, insects, and curious critters. The other end connects to the house. Many systems include a high-quality air filter before the air enters the living space. A small, inline fan gently pulls fresh air through the buried pipe. These fans often use surprisingly little electricity, far less than a central air conditioning system. As the air travels through the cool ground, some of its heat naturally transfers into the surrounding soil. By the time it reaches the house, the temperature can be noticeably lower than the air outside. Exactly how much lower depends on several things: your climate, your soil, the length of the buried pipe, ground moisture, airflow. No two installations perform exactly the same. That's something worth remembering, because if someone promises identical results everywhere, they're probably oversimplifying the story. Nature doesn't work that way. Old Ben has learned that lesson more than once. Now, another question folks often ask me is, what about humidity? That's an important one. In dry climates, earth tube systems can work remarkably well with relatively few moisture concerns. But in humid regions, things become more complicated. Condensation has to be managed correctly. Drainage becomes essential. Regular inspection matters. That's why many modern designers choose a different approach altogether. Instead of blowing air directly through buried pipes, they circulate a closed loop of liquid underground. That liquid absorbs the stable temperature of the earth, then passes through a heat exchanger inside the house. The air stays inside. The liquid stays inside its own sealed loop. Two separate systems, working together. It's a more complex design, but it greatly reduces concerns about moisture inside underground air pipes. Sometimes the old ideas evolve, not because they were wrong, but because we learn how to improve them, and I think that's an important lesson. Forgotten knowledge doesn't mean refusing modern improvements. It means respecting the wisdom that came before us, then combining it with what we've learned since. Because the goal was never to live in the past. The goal has always been the same: build smarter, waste less, and leave something better for the next generation. Now, before you go, next week I'm taking you into the hills of Kentucky to uncover a forgotten water system that provided clean drinking water without electric pumps, expensive filters, or modern technology. It's a story that's almost been lost to time, and once you see how it works, you'll never look at water the same way again. So if you believe the old ways still have something to teach us, subscribe to Old Ben's Secrets. Until next time, work hard, stay prepared, and never let good knowledge be forgotten. I'm Old Ben, and I'll see you in the next one.